The students of Electrical Engineering Department of Gyan Ganga Institute of Sciences and Technology have done a never before wonderful work of setting up a laboratory for testing of high voltage power transformer. This is something unique, as the responsibility for setting up of any laboratory rests on the department and the institute and not on the students. I would like to explain as to how they have been able to do this work. Power transformers are required to be tested as per IS 2026 before leaving the factory, so as to ensure that they conform to the required standards and to ensure that they will be giving satisfactory service once they are installed in the field. Each transformer is required to undergo routine tests, and the major routine tests are measurement of winding resistance, number 2, measurement of insulation resistance, and then 3, separate source voltage withstand test. This is a high voltage test, 28 kV required for 11 kV transformers. 4th is the induced over voltage withstand test, that is double voltage double frequency test. Next to this, 5th is the measurement of voltage ratio. 6th, the measurement of no load losses and current. 7th, measurement of load losses and impedance, efficiency and regulation, etc. 8th, the verification of vector group between primary and secondary windings. And the last major test as per routine test requirement of IS 2026 is breakdown voltage test of oil which is filled in the transformer as insulant and coolant. For carrying out the routine tests required as per IS 2026, in addition to the normal measuring equipments like ammeter, voltmeters, wattmeters, etc., the major testing equipments are 28 kV separate voltage source with standard test equipments, proper protections, etc. Next is a voltmeter to measure the high voltage. Then the double voltage double frequency test setup and oil breakdown voltage testing equipment for measurement of percentage impedance and also for measurement of load losses. A voltage booster along with control equipment is also needed. For winding resistance measurement, low resistance measurement meter, and for turns ratio, a turns ratio meter is needed. For insulation resistance, a Megger or insulation tester is needed. I would like to explain that All these major equipments which are needed for routine testing of a high voltage 11 kV transformer have been developed by the students of electrical engineering department as their minor and major projects. None of these equipments have been purchased from the market, but have been designed and fabricated in the institute and have been successfully assembled and tested for the requirements. All these equipments have been developed in a span of nearly 4 years or so, and all these have been planned in such a way that they have been coming up one by one, with the result that a complete high voltage testing laboratory has been set up by the students of electrical engineering department. This is, I believe, a great achievement to the students. It is not only the testing equipments which have been designed and fabricated by the students, but even the transformer under test, a 11 kV, 25 kVA transformer, which is under test by these equipments, has also been designed and fabricated by the electrical engineering students. This is the transformer which is under test. This is a 11 kV oblique 0.4 kV power transformer having a rating of 25 kVA. This has been designed and processed in the college by the 8th semester students of electrical engineering department. This is 28 kV voltage source which is required for testing of 11 kV transformer as per IS 2026 requirement. This is the main transformer which develops single phase 28 kV, and this is the control unit for this separate source testing setup. This is voltage booster which is required for measurement of load losses and percentage impedance of the power transformer. This has been designed and fabricated by the batch electrical engineering department. This is a control unit for sphere gap type voltage measurement. Sphere gap measurement is a classical method for measurement of high voltage, and even for 400 kV transformer for voltage calibration, this method is in vogue. This sphere gap voltmeter has been designed and developed by the electrical engineering students. Depending upon the density of air between the sphere gaps and the size of the sphere gaps, the breakdown voltage is dependent on the distance which is kept between the two spheres. The density of the air between the sphere gaps is dependent on the barometric pressure and the temperature of the ambient. As such, if we know the barometric pressure and the temperature along with the size of the sphere gaps, then depending upon the distance which is kept between the two sphere gaps, the breakdown voltage can be determined. These sphere gaps have been set for 28 kV spark over voltage. On achievement of 28 kV, a spark is there. This is transformer oil testing kit, which is used for measurement of breakdown voltage of transformer oil. On the top of the unit, there is oil test cell, which is filled with the oil which is under test. The sphere gaps have been designed as per the requirement of IS applicable for breakdown voltage testing of oil, and this test kit is able to develop up to 98 kilovolts, that is 90,000 volts. The gap between the two spheres is kept as 2.5 mm as per IS requirement, and the voltage developed by the kit is gradually at a constant rate is increased to give a spark. No sooner the spark is there, the test setup comes to a standstill, and the voltage at which spark has taken over is captured by the voltmeter. In this case, transformer oil under test has given a breakdown voltage of around 34 kV. The oil which has been tested was taken out from the transformer in service. This equipment is fabricated and developed by the students for development of double voltage and double frequency. The rating of the transformer is 11/0.415 kV, and as such the double voltage requirement is around 830 volts. With a simple arrangement made by the students, the existing DC motor coupled with AC generator is able to develop double the voltage, that is around 830 volts, and double the frequency, that is around 100 cycles. With change in the excitation of the motor and by using a pulley arrangement, the measured voltage is around 846-45 volts, and the frequency is around 100 cycles. This meets the requirement for the testing. This is nearly 100 cycles per second. The transformer is under test by the testing assistants of the laboratory. This is a protection arrangement which has been designed and fabricated in the institute. As per IS requirement, 60 seconds is the time for which the high voltage and double voltage double frequency test is to be conducted. This arrangement automatically cuts off the applied voltage after a lapse of 60 seconds time. All transformer primary and secondary terminals have been brought out. In order to protect and in order to ensure that the safety norms are suitably adopted, an interlocking arrangement has been designed and made applicable. The complete testing premises wherein high voltage development is there is switched off no sooner the door is opened. These are the faculty and technical assistants who have provided guidance to the students for development of various testing equipments required for setting up of high voltage transformer testing laboratory.